Okay, this video is some 6-3 problems. These are right from the book. So this is page 347. I'm going to do 17, and then we'll see how much time we have. 20 and 22 is what I'm thinking. So I'll warn you, 17 gets to be a little weird. So you know it's integration by parts. It tells you in the directions. And so we want to think Lipit, which is logarithm, inverse, polynomials, exponentials, and trigonometric. Now I can tell you I've done this problem both ways, and it doesn't matter that much what you pick. I'm going to go ahead and pick u equals sine of x. So that's my trig, which would normally be my last. You could do u equals e to the x, and you're going to get to the same ending. You'll see this ends kind of strange. So then my dv is going to be e to the x. Okay, so remember here I'm taking the derivative, so let's recall I always have to write this. These are my derivatives because I just have a habit of messing up those negatives. So derivative of sine is cosine. So du is cosine of x. And then if I'm going backwards from e to the x, I'm always going to get e to the x. Okay, so u times v would be sine of x times e to the x minus the integral of your voodoo v du. So v is e to the x. Du, I should have a cosine on here, is cosine of x dx. Okay, so this is kind of like the integral we already did. So you might be thinking maybe I should have done this tabular. Let's keep going though. Let's do this again. The other thing I'm going to do right now is I'm going to remind myself the integral that we're solving for, and that's just because I know where this problem is headed. So I'm going to say this is what we started with. And this is where I'm at, equals all of this. Okay? All right, so this is stays. This is part of my answer. I need to do this integration by parts over here. So again, I'm going to let u equal the trig function cosine of x. So du would equal negative sine of x dx. And I'm going to let dv equal e to the x. So if I antiderivative of e to the x is e to the x. So remember, this is antiderivative. This is derivative. So now I'm doing u times v minus the integral of v du. So u times v is cosine of x times e to the x. I'm going to put the cosine of x in front, minus integral of voodoo, which would be v du. Okay, so I'll write it as minus e to the x sine of x dx. And you might be thinking, I'm getting nowhere with this problem. I have another integration by parts here. Now I'm going to bring down and copy the rest of this. Remember, before out front I had this. I should probably maybe do some brackets there because this is a minus. And then the original problem I'm solving for was this. Okay, not going to do number 20 right there. I ran out of room. Now I want you to notice something. If you look at what we were originally solving for, e to the x sine of x, you can think here is the original integral that I was solving for again. So picture like this is my unknown and this is my unknown. I can write an equation now where I have all of this on one side and everything else on the other, and what I have on the other side will not be an antiderivative. So first thing I want to notice here is I have minus a negative, so I'm going to make that a plus. And I'm going to get rid of this negative. Should probably do that in another step, but we'll do it like that. Now, let's gather all of the integral of e to the x sine of x dx, e to the x sine of x dx, on one side of the equal sign. Let me distribute this negative here, which would make this negative again. Okay, so I guess I can get rid of these brackets. So I want this whole integral over here. Think you want to gather what you're solving for on one side. So I would add this to both sides. So over here, I would have 2 times the integral of e to the x sine of x dx, because I'd be adding these two together, equals e to the x sine of x minus e to the x cosine of x. This is gone. Now look, this is what I was originally trying to solve for. If I divide both sides by 2, I have my answer. So I'm going to have 1/2 times all of this. Probably on a multiple choice, I think they would likely factor out this common e to the x. So your answer would probably look like this. The 1/2 would be on the outside. Factor out an e to the x, and I would have sine of x minus cosine of x. Ooh, and don't forget your plus c. So they do factor out common terms a lot, so I think this is what my final answer would be. So these are just weird ones. You have to kind of be on the lookout. You'll notice right away, you'll feel like you're getting nowhere in the problem. And then you might notice what you're solving for originally shows up in your answer. So then you want to gather all of those on one side of the equal sign and solve for them. Let's look at 20. I think it might be similar. So number 20 is e to the negative x sine of 2x dx. Yeah, it looks like it might be similar. Just a little bit messier. Let me make sure I copied that right. Yes. Okay. So I'm gonna start this one with u equals e to the negative x. And then dv will equal sine of 2x. This is chain rule. Derivative of the inside would be the derivative of negative x, so that'd be -1. Derivative of outside would be e to the negative x, so that the derivative of e to the negative x is negative e to the negative x. Okay, this is, I'm doing the antiderivative of this. This is a u sub, because this is a composition. So u would equal 2x, du would equal 2 dx. Oops, I should have a dx on here. So 1/2 du would equal dx. So this integral would become 1/2 sine of u du. I can pull the sine of u, or I'm sorry, the 1/2 out front. So antiderivative of sine is negative cosine, so I'd end up with 1/2, negative 1/2 cosine of u, or negative 1/2 cosine of 2x. So v would equal negative 1/2 cosine of 2x. Okay, let's see, did I do that right? Sine, antiderivative of sine is cosine, and a negative. Okay, now, so that was all just to get my u du v dv. Now, let's set up our integration by parts. Now, I'm going to do this one like this. This is the integral we're solving because I kind of know where I'm headed now. So u times v would be negative 1/2 e to the negative x cosine of 2x minus the antiderivative of voodoo, which would be v du, so these two. So it looks like I got a negative and a negative, so that's going to be a positive. And then I'm going to have 1/2 e to the negative x